Let's take a few minutes now and look at the front of the SL8500. I'll go ahead and start the robots up, and then I'll explain a little bit about our design. Just going to kick off an audit. One of the things you may notice looking in the front is that the shape is very different. Up until now, there were two fundamental shapes for libraries. There were linear designs, and then there were circular designs. In the past, we had chosen circular over linear for two reasons. One is floor space. So if you look at a circular design, if you stretch it out to make it linear, it just takes up a lot more of your data center floor space. We didn't want to do that. Second thing on linear is, by definition of the word, there's one and only one way to grow. So as you add more drives, more capacity, and fundamentally more work to the system, that same robotics has to travel further and further to handle the work. So in reality, your performance goes down when you need it to go up. That can work okay, linear can work okay for an archive, but not so good for everything else. So our objectives for our engineers were, number one, you have the best floor space, make that better. Number two, you have great performance, see if there's something you can do better on that. And then number three, do that one piece you can't do in a circle, and that's replace a robot while it runs. So if you recall, the last piece of high availability we spoke about on the back was replacing robotics. I'm going to show you how now that I'm in the front. So let's take these one at a time. In terms of shape, by taking that big motor out of the middle of the library and actually putting it on each robot, we freed up a lot of space. We then broke the circle open to a U and compressed it. So it is about 25 to 50% less floor space than our previous libraries, which were best in class. For performance, as you look behind me, you notice we have 8 robots in here working in parallel. Why did we do that? Well, nobody buys a large library and connects it to one PC running one task. So what a library sees are a whole bunch of servers sharing it, and it sees asynchronous mount requests. So we're multi-threaded. We can do 8 things at once instead of one thing at a time. That helps on system performance. For the last piece, replacing a robot while it runs, what I'm going to do now is take one of the robots offline. So it'll be simulation of if it had an error. And what you'll see is this particular robot here, as soon as he's finished that task, will come to the front and park himself in the service bay area. The next thing you'll see is that his twin will actually come over and pick up his workload for him, so that no jobs get missed. So you notice all the robots are still working in parallel, and his twin comes over and picks up his audit right where he left off. Okay? The next thing that would happen is our service tech would then come here and turn this key to activate the service bay door. And then this door will slide across as you see now, so we can replace that robot while the whole system continues to run. So our service technician will show up with a replacement robot, and notice we're not replacing just the gripper, but the entire robot. A couple of things about the robot. Number one, he actually has 2 motors and 2-wheel drive. So even if a motor breaks, the other motor is good enough to power the robot into the service bay area. If something should happen and the robot is unable to move itself into the service bay area, his twin would actually have pushed him into the service bay. At this point, our service technician loosens 2 screws, removes the entire robot, and would hang a replacement robot. We would then turn the service safety door back to the center position, and you'll see it slide across there. And at this point, I can bring the robot back online and he'll go back to work. The other thing that the U-shaped design gives us is 2 ways to grow. So if you go back to our story on linear, there's only one way to grow a line. Likewise, with circular design, there's only one way to grow, which is via pass-through to another circle. With the U-shaped design, we can do either or both. So we could take the U and grow it lengthwise to build, for example, an archive. And we can also attach them side by side via pass-through. So let's take a walk over to the side, and I'll show you those 2 ways to grow. Let's take a look at how the SL8500 can scale. The base machine comes with a back piece that houses all the drives, the back of the U, and then the front of the machine. In this configuration, it houses 1,448 slots. To grow it, in between the U and the front, you can have 0 to 5 of the expansion units, each of which is 1,728 slots. So with 5 of them, that takes us to 10,000 slots total. To allow you to grow without an outage, you can purchase the expansion frames up front, we can install them, and you can license the slots later. That allows you to grow all the way up to 10,000 slots. Let's talk about the other way to scale the SL8500 via pass-through. There are 2 key things that are new on the SL8500 pass-through. First, it's quad redundant, so that way should a mechanism fail, we can actually replace it from the rear while the whole machine and whole system continues to operate. Secondly, can it be attached hot while the first library continues to run? So let me walk through an example. So if you have a SL8500 of whatever particular size and it's time for you to grow and you want to add more drive bays, you want to add more slots, and you want to add more robots to service the additional workload, you can order a pass-through port and a second SL8500, and we can attach it while your first system continues to run. You don't have to schedule an outage. So while that first library is running, we would pop off the cosmetic skins that would be here and here, attach this pass-through frame with the 4 mechanisms. It'll continue to run. The actual slots where the pass-through goes through are always left vacant in every SL8500 we ship, so everyone is built to scale while it runs. After we attach the pass-through, we would attach the second library where I'm standing to the pass-through port. Meantime, the first library continues to run. The second library would go through its initialization and audit and then report into the first library, thereby the whole system growing without taking any scheduled outage. Let's go take another look at the front of the machine now. Let me show you just one more feature in the front before we conclude. If you're designing a library, this is actually a pretty nasty problem. And it's actually worse than I'm showing you because all 3 dimensions are different. And it's worse than I'm showing you that this is LTO. This is our fast access dual hub 9840. We also do the SDLT cartridge, which is yet another set of 3 dimensions. So if you're designing a library and you have to accommodate that, it's pretty tricky. So what most vendors do is they come to you and say, well, how many slots of this do you want and how many of that do you want? They build that for you and that works for you on your first day, but then life changes and so do your needs. And that would require an outage as they reconstruct your library to your new requirements. What we ask our engineers to do is, let's make this our problem. We would like any of these to go anywhere in any combination. So how did they do that? Well, you notice the notch in the larger cartridge. Every slot in the library, not just the cap here in the front, but everything in the library, has fingers in it so that the larger cartridge slides deeper and the shorter one not as deep. As these slide into the slots, we don't care about the height difference at all. The robot always grabs from the side and grabs via pressure. So even though the depth is different, the height is different, the length is different, the robot can always hit the same spot on any cartridge and put anything in any slot. As you can see, the SL8500 has many innovative features. Prime among them are its ability to make consolidation much easier, to provide the highest possible availability, and to help save on your environmental cost. Please feel free to contact Sun Microsystems and we'll show you even more of its features as well as our other enterprise solutions. Thank you.